Okay, yes. Anyways, let's start because we only have today 1 hour and a half for this event, for this workshop. Let me 2 minutes to do the introduction, and then the first speaker, Jordan Last, can start to present. Yeah, welcome everyone to the Blockchain at Michigan workshop organized by Definity Foundation and Lumos Labs, and for sure for Blockchain at Michigan. Today we have a super interesting guest, super interesting topics for the Michigan students and in general for software developers, because the event is open for everyone. Our guests today are outstanding. The first speaker will be Jordan Last, the founder of Demergent Labs, that will present during 45 minutes, and he will teach us how to use Python CDK to deploy dapps on internet computer blockchain. And then the second part of the workshop, during another 45 minutes, Kanishk Khurana, software developer as well in Lumos Labs, software relation at Lumos Labs, will share with us insights on the various software development kits and tools like Covalent, Bioeconomy, Push Protocols, Polygon, Infura, and much more. Before I start, I want to thank all the participants for your interest and support today. Thanks also to the team Blockchain at Michigan to make the event possible, for sure. Ashish Patel, the president, Sohavni Singh, the vice president, and the rest of the Blockchain at Michigan team. Thanks a lot. Thank you as well to Lumos Labs, especially Kurian Zakaria, who helps and support me in every event we have between Lumos Labs and Definity Foundation. And finally, many thanks to the two fantastic speakers that we have today, Jordan Last, the Demergent Labs founder, and Kanishk Khurana, developer relations at Lumos Labs. Okay, let's start with Jordan Last. Just a quick introduction. Jordan is a full stack software developer focused on the web, distributed systems, blockchain, security, and open source. He's the founder of Demergent Labs, an organization that is building on internet computer through different programming languages. TypeScript CDK is Azle, GraphQL, Sudograph, and Python Kybra. Thanks a lot, Jordan. Yeah, all yours. Last thing, if you have questions, we have like 10 minutes for the Q&A at the end of the presentations, more or less. All the questions that you have, you can drop on the chat, on the Zoom chat, okay? Thank you so much, all yours.
Cool, awesome. Just want to make sure you can hear me and everything?
Yes, we can hear you perfectly, yeah.
Okay, awesome. And then real quick, just to get a read on these people, who here knows, like, what do you guys know about the internet computer? Have you heard of it before? If you guys could maybe answer in the chat if you've heard of the internet computer or not. Okay, so, okay. Oh, wow. Okay, so sweet. Okay, well, that's good to know. So, sorry. Yeah, so some of you know. I guess I won't go into super in-depth detail on the internet computer, but let me just give a quick overview just in case, and then I'll lead into the, I guess, Python development on the internet computer. So the internet computer basically is you could think of it as a blockchain. Definitely has a lot of characteristics of a blockchain. If you're more of just a normal, web developer or just kind of tech person, you could think of it more as just a decentralized computer. It's basically it's a new type of computer. Bitcoin introduced this new type of computer back in 2008, at least the first very, very successful version of this. And it's decentralized, it's replicated. So you don't have your process or program running just on one machine that can be shut down, if the power goes out, or if someone closes their laptop, or for whatever reason, it gets shut down, or if you even have like an EC2 instance on AWS, having that single central point of failure causes potentially lots of problems. So the internet computer builds in replication so that automatically any application you deploy is going to be replicated right now on at least 13 nodes, as high as, I believe, 40 nodes. And they try to make each node or replica operated as much as possible by independent entities spread across various continents, countries, jurisdictions throughout the world. And this is all to help ensure, reducing the central points of failure, essentially. So this is a replicated compute environment. You can think of it just as a cloud with replication built in. It's also a WASM environment. So the actual execution environment or the runtime is a WebAssembly runtime, which is pretty awesome. WebAssembly is not just for web browsers. And what this WebAssembly runtime gives us, it gives us some pretty awesome security benefits like the built-in sandbox and the formal verification of WASM. It's very rock solid, battle tested, a bytecode format and virtual machine. But also WASM, well, it's kind of designed to be a universal compilation target. And so we are able to compile various languages into WASM. We don't just have to rely on one or a few languages. Right now there's a few, but the potential is to have possibly all languages in the future. So right now, Rust is very, very well supported. It's a very low level language built for straight up software engineering. It's a very difficult language to learn and get used to. Motoko is a language that Dfinity created itself, a domain specific language for the internet computer. It's a general purpose programming language, but it was created specifically for the internet computer, so it doesn't really have any usage or adoption outside of that. And then my company, Demergent Labs, currently we were funded by a grant from Dfinity. We are bringing Python and TypeScript to the internet computer. So essentially what we've done is we have compiled a JavaScript environment to WASM and a Python environment to WASM and hooked up all of the APIs that you need to interact with the internet computer environment. And yeah, I mean, it's pretty simple. It's just TypeScript on this decentralized computer or Python on this decentralized computer. We're also building a GraphQL database. So all these tools together, the point is to make a very, very simple developer experience, hopefully the best developer experience that exists on any platform where everyone tries to do this, but you just have to write your code and your logic and then deploy it. That's the point and the purpose. So yeah, if you have any questions, I just throw it in the chat or something. I'll share my screen soon, so someone might have to interrupt me. But if you have them, just throw them in. And worst case, I'll just answer them all at the end. So yeah, today I'm going to focus on the Python environment in particular. This project is called Kybra, and it's a canister development kit for the internet computer. What's a canister development kit? It's like any other software development kit. It's just called a canister development kit because a canister is the fundamental application unit on the internet computer. So, a normal, like a web app backend, you call it a web application. On the internet computer, you call it a canister. It's the code of your application combined with the state or the memory of your application. That little unit is a canister. So Kybra is a canister development kit. So I need to share my screen, but it says I can't do that. Let's see.
Let's try now.
Okay. Yep, should be able to now. All right. Is it sharing?
Yes, it's sharing.
Awesome. All right. So, oops, just a second. Okay. Also, Python is not my preferred language, so I'm a little bit rusty. I mostly am kind of programming Python itself, not usually programming in Python. So forgive me for that. But we're just gonna basically start from scratch and build up a simple program and kind of talk about all the various concepts along the way. So if you want to build an application for the internet computer or a canister, starts just like any other app. You just need to start with a directory. So let's just do a simple hello world. Okay. Nothing in here, completely empty. Let's just load this up in Visual Studio Code. That'll be nicer for everybody. So I just organize my stuff how I organize it. You can organize your stuff however you want. Where did I put this thing? What the heck? Hold on. Oh, Kybra, Michigan. That's what it's called. Sorry. Here we go. Hello world. There we go. Just an empty directory. Nothing in here. So let's make it a Git repo. All right. Now it's an actual Git repo. That'll just help us hide some stuff. It's also, this is a Python project, so we're going to start up a virtual environment. Now, Kybra, by the way, right now the main documentation is just in the GitHub repository. So github.com/Demergent Labs/Kybra. Put that in the chat here. Oh, I see a question. What's your preferred language? Basically, I love TypeScript and I love Rust. So those are the languages I've written the most. I do like Python. I just, I haven't been in the weeds programming in Python for the last week or two because I've been focused on Azle, which is the other CDK. So, and Azle, by the way, so Azle is the TypeScript version of Kybra. I just want to show you this because Kybra will soon have its own book as well. This is the Azle book. Just got published. It's not finished, but has quite a bit of stuff. So Kybra will be getting the same treatment very soon. But for now, you just have to deal with the GitHub repository. So yeah, if you just go here and follow the steps, it kind of tells you everything you need to do. Right now, just to make sure there aren't any problems, it is highly recommended to use this very specific version of Python, Python 3.10.7. We recommend using PyEnv. That's just a very nice, clean way to install it, and we know exactly where the binary is and everything. So I'm personally using PyEnv on my machine. And DFX, you also need to install. This is just the Dfinity or Internet Computer Command Line tool thing. So you just run this command, also super easy. And then in VS Code, we are recommending the Python extension by Microsoft, which uses Pylance. And something very, very interesting if you're not, well, if you are a Python developer, you might not be used to this, but we are using static types, which I think is absolutely fantastic. So you actually need to use static typing in your Python to program on the internet computer using Kybra. So I'll show you how that works. But yeah, you just kind of install this stuff. Nothing crazy. Sorry. Did someone say something? Okay. Yeah, get this background stuff installed. It's not too bad. And then finally, we get into the actual meat. So we start by creating a virtual environment. So this is just a normal built-in virtual environment command. I'm just specifying the path directly to the binary so I know exactly which Python binary that I'm using, and it's the exact version that I want. So this will just create my virtual environment. So here it is. Now it's the Git repo. I don't really want to see all that stuff, so let me just make a git ignore real quick and ignore that virtual environment. Okay, awesome. Next, we need to source our virtual environment. So you just use the normal source command. Here we go, we're sourced. Next step, we want to install Kybra. So it's a simple pip install. There you go. And we want to boot up our replica. So if you use the dfx command line, you can just say dfx start, and that's going to boot up basically a local instance of the Internet Computer blockchain or the Internet Computer node or whatever, just one of them running on your local machine. So there it is, it's running. And I'm going to open up another terminal and source this terminal as well. Okay, so we've got our replica running and we don't have much else. So next step is, I guess, let's just make our source directory. And this is where we're going to put our source code. So by convention, we're using main.py. I think you can name anything you want, but I recommend just using the main.py convention for now. It's kind of what we're building it around. And then you just import stuff from Kybra. So from Kybra, let's import query. It probably hasn't figured out that I installed it yet. So sometimes you'll need to just reload, and then it should be able to pick up that Kybra is installed into the virtual environment. There we go. And then, so sorry, I didn't explain what query is. The most basic way that you expose functionality from a canister or an application is through canister methods. In Kybra, these methods are just functions. And there's two main types of methods that we'll go over today at least. And this is how generally you'll expose your functionality. One is called a query method, and one is called an update method. Query methods are read-only methods. So let's make one. Hello world. It returns a string. You have to actually put the type in. And I'll just say hello world. There we go. So this is like the most basic canister you could possibly make. It has one query method, and it returns the string hello world. Pretty simple. It's read-only. There's no state changes. There's no consensus here. So because the Internet Computer is a decentralized computer and it's replicated, to achieve security whenever you change state or change your variables, the blockchain or the computer runs a process called consensus, which basically means all the nodes have to agree on the change that happened, and they all commit that change. A query method does not go through consensus because it's read-only. So it's very quick to execute, and yeah, just the most basic thing you can do. Okay, one more step before we can deploy this. We actually need to make a special configuration file. It's called the dfx.json file. And this is just a file that tells the replica or the Internet Computer, basically DFX, where your canisters are and what their names are and everything like that. So it's easier to just copy paste. And here we go. It's all filled out. So we have one canister called Hello World. This is a little complicated. We are going to make this a lot simpler in the future. You'll be able to say type Kybra and just point straight to your main.py. But for now, you just have to do this. So here's your build command. Here's your candid file. We'll go over what that is. And then finally, your the path to your actual WASM binary. This is the actual code that is the bytecode that's going to be actually deployed to the Internet Computer. So there you go. Just copy paste it, change the names, and you're good. Okay, we're ready to deploy. So you run the dfx deploy command, which will start the compilation process. So keep in mind, Kybra is in beta, so sometimes things take a long time to compile. I've already pre-compiled this a few times, so this is the normal speed at which it will compile. We are hoping to be able to get it down to around like just a few seconds, but there's just some stuff we're waiting on from Definity and such. So it takes about 20 to 30 seconds. Once it deploys, we can interact with it from the command line or from the browser. There's a nice little built-in UI. And in this case, well, I'll just start from the command line. So, okay, it's deployed. From the command line, you can call your canister like this, dfx canister call. The canister's name is hello world. And yeah, okay, the method is also called hello world. So that's a little bit, so you just say dfx canister call, put in the name of the canister, and put in the method name as well. And we'll execute that, boom. Hello world, that is exactly what we told it to return. You can also do this from, you can do this from the browser. I'll show you that real quick. So here you go. This is the same thing. I'll just query it, and there you go, hello world. So not bad. All right, so that's a query method, no consensus, super fast, read only. Now, if you actually want to do anything, you're going to need to persist your changes, right? You need to be able to store things in there. So for that, we need the update decorator, and we'll create an update method. So let's make like a kind of a simple setter and getter. So change this to get message, and let's make a global variable up here called message. All right, so get message will return whatever the message is, and then set message will actually set this. So let's make a parameter. There we go. Okay, we've got a simple, let me just deploy this while I explain. This is a simple getter setter on here. So this is now an update method. Any state change, so we're changing the state of this message variable. This is a global variable. It'll be stored on the heap. And the heap will be automatically persisted across update calls. So once we execute this update call, this variable will actually keep that message inside of it, which is fantastic. Like this, it's a very, very simple developer experience. Now, update calls go through consensus. So all the nodes have to agree on this change. And so it's going to take a couple seconds in production, maybe 2 to 5 seconds, which sounds reasonable. It's faster locally. So, oops. It's asking me if I want to introduce a breaking change, which I do. Okay, it's deployed. So I'll show you the UI for now. Okay, so we've got get message set message. So let's get the message. It's empty. That's exactly what we set it to, right? And then let's set a message. Hello there, sir. Oh, let's go through consensus. Okay, took about 2 seconds. And now if we query, you'll notice, boom, there's our message. And we can set this to any string, essentially. There we go. Perfect. Nothing crazy. And same thing on the command line, right? dfx canister call, hello world, get message. There you go. Set message. This is the new message. Same idea. And if we query it, there you go. Perfect. Okay, this is, kind of contrived, nothing too crazy. So let's up the ante a little bit. So let's actually start making like a database of sorts. Simplest database I can think of is maybe a simple key value store. So we'll just make a dictionary. The keys will be strings, the values will be strings, and we can make this a general purpose getter. Pass in your key, which is a string. Now, importantly, we're going to make this optional, which means it could be none. And we'll import opt from Kybra. And we'll say db.get for the key. And if the key is not there, then we're going to return none. There we go. And we'll change this setter. Take a key and a value. And it will simply set the key with the value. So let's just deploy that real quick. I'll say -y so that it won't ask us if we want to introduce breaking changes. Okay, simple getter setter. Our database is just a dictionary. with keys and values. Nothing too crazy is going on here. By the way, starting your DFX replica will put this .dfx directory in your repository. So let's just ignore that. And then Kybra creates a .kybra directory, so we can also ignore that. Also, Kybra will generate your candid file for you. Candid is an interface description language that Dfinity created that basically allows you to statically type your entire canister with all the methods and with all the types. It makes it really easy for interoperation between canisters and between different languages. So that's what this candid file is. Generally, it will just generate it for you. So if you're happy with what it generates, that's good. You can't actually manipulate this right now, but in the future, we might allow you to do that if that's something that you really want to do. But hopefully we can actually even get rid of the candid file and hide it for you. Motoko does that, which is really nice. So, all right, it was deployed. Let's just use the web UI. So let's get, this is a key. Well, null, opt string. If it wasn't there, it returns none. Now let's set something. 0 is fine and 0. And let's do 1, 1, and 1. So this is just a little database. Actually, probably build a pretty awesome application just for this, if you had to. So let's get that. There we go. 0's there, 1's there, and 2's there. Okay, pretty awesome. So, yeah, this is good. There's a couple problems here. One is, these types are like really simple, right? Probably want some more complex types. And also, there's a little nuance here. Whenever you upgrade your canister, it's going to wipe your memory or your heap. So anything you store in this database after an upgrade is just going to get erased. So let me show you. Let's just deploy. This will upgrade the canister, and you'll notice that our entire database will not exist anymore. Oh man, that last step takes a while. Like I said, we think we can get this down to like 5 seconds or less eventually.
Yeah, meanwhile, Jordan, maybe you can answer one question about Plan.
Sure.
Abraham and as well Michael Gallegos.
Yeah. Let's see, what questions do we have here? Candid? I think I addressed that question. Let me know. I showed you the Candid file. It's an interface description language. What are you waiting on with regards to the deployment? Oh, being faster? No, it's not Python. It's the fact that the limit for the WASM binary is really small. It's 2 megabytes. And the Rust Python interpreter we're using, the binaries are much larger than that. And so we have to do all this crazy optimization, like use all these crazy tools to try to shove the binary to make it really small. All that tooling just creates this really long compilation and optimization process. So once they increase the binary limit, we can just remove all those tools and lots of steps. And it should hopefully only take as long as the Rust compiler actually takes, like the Kybra compiler that we built, which you can see that step right here is just a few seconds. So that's going to be the best case scenario. You'll still have to like install Rust and everything, which we do for you, by the way. You don't have to think about it really, but that shouldn't take too long. It's really just the WASM binary being huge that ruins everything. Can you generate an II or log in using II with Kybra? Yes, you definitely can. II doesn't care about your backend, so you just use Kybra and your II will be there, as far as I know at least. And you get the caller. So if you import this IC object right here, then you can grab the caller principal like that. So if someone logs in with their identity and does an update or a query call, then you, well, actually, I don't think caller works in query, but you have the same authentication as everything else. So I think I answered those questions. Okay, so now to show you what just happened. Our database just got entirely wiped, which is not good. So to fix that problem, really what you want to do is use a special data structure called a stable B-tree map. This data structure is it's so much a dictionary. It's just like a map. You have keys and values, but it will be persisted across canister upgrades, and you get way more storage. So on the heap, which is what we're using here, you are limited to basically 4 gigabytes. But if you use a stable B-tree map, you get up to 48 gigabytes, which is pretty sweet. So let's do the same thing using a stable B-tree map. So let's say our database actually is a stable B-tree map. Same types. Now you have to provide a memory ID, which is just a unique identifier for this stable B-tree map. So we just start with 0. Unfortunately, for now, you have to give a max key size and a max value size. This can be really tedious and annoying because you have to figure out the max sizes. That's just the way it is for now. We're using the stable structures that Dfinity created under the hood, and they haven't figured that out yet. But it looks promising that they'll be able to remove that requirement. So hopefully this is just temporary. Okay, so this is almost exactly identical. db.get key, and the get on the stable structure automatically returns or none. So we're good for the opt. And then what we'll do here is we'll say db.insert the key and the value. Sweet. Now, really, you're going to want to handle the result here. So insert returns and insert result, which is basically a class or an object or a dictionary or whatever. It is an object actually in this case, and it has 2 properties. One of 2 properties: err or OK. If the error is not none, then you have a problem. So you'll want to do something like that. Easiest way to do that for now, just for this example, is to just raise an exception. I don't know if that will do what I think it will do, but you get the point. And then the actual result is now inside of result.ok. So that's the actual result of inserting. This is a very important concept to learn on the internet computer. Rust has it, Motoko has it, and now Kybra and Azle have this concept of results. Basically, OK or error, and it will not be both. OK, so here we go. We've rewritten this now to use stable B-tree map. This is the recommended way to actually do things, and we'll give it another deploy. And then while that's deploying, probably the last thing I'll be able to show you is how we can make this a little bit more complicated and introduce the concept of a record. So a record is, I mean, it's like a class or a dictionary, but it's the internet computer type or the candid type that lets you define a generic collection of key value pairs. So how we make these in Kybra is with the class, and we inherit from record. We can give it an ID, give it a, oh, oops, sorry, TypeScript. A username, maybe we could put an age on there. Yeah. It's not the best. So you probably want to use like a nat, at least like a nat16. These types I'm importing, by the way, a lot of these are candid types. Candid is, like I said, that interface description language, and it comes with all these types that Kybra and Azle will give you. So, you know, bool is just bool, but we've got blobs, float 32s, float 64s, a bunch of different ints, a bunch of different nats, nulls, principals, records. All these things are candid specific, and Kybra lets you use them. but you'll need to use the candid types in your canister methods for the parameters and the return types, and for your stable B tree map, and basically for a lot of the internet computer functionality. So we'll just start with this for now. This is a very simple record called the user. We should be deployed. So let's redo this real quick. Okay, so now our database has something in it, but we can redeploy and it will not lose all of our stuff, which will be sweet. Okay, while we're doing that, let's replace our stable B tree map value with a user. So this is becoming more like an actual database, right? The keys are strings, so it could be some crazy random identifier, hopefully a universally unique identifier. And then our values will be users. So here we'll want to actually return a user. Okay, and nothing changes there. And here our value should actually be a user. And again, nothing changes, so not too bad. Once this deploys, let's just prove that the value is still there. So before it was wiped, now if I query it, it should still be there, and it is. So that automatically persists across upgrades, and you have up to 48 gigabytes of storage, which is awesome. And now we'll just redeploy this again, but this time we have a more complex type in our database. And then I'll just show you a couple operations on that. And then I guess maybe I'll answer some questions, and that'll probably be it for my Kybra demo. And you can do all kinds of other things too. There's a lot of things we didn't get to. This book is just so awesome. So let's just look at this. So we went over query methods, update methods, candid. Again, you have all these types available to you. Stable structures we just went into. What we haven't gotten to yet is cross canister calls. So this lets you actually communicate with other canisters on the internet computer. There's also HTTP functionality that Kybra exposes to you so that you can receive HTTP requests and basically be a web server. You can also make HTTP requests and talk to normal web infrastructure. All right, this has refreshed. So now if we try to get a user, what's wrong with this? Well, I don't know what's wrong with that. Well, let's see if we can at least set it. Maybe the demo will break down on this, but let's say our user ID is 0. So the key is 0. We'll make the ID 0. The age, like, I just turned 32. So let's do that. And then last.js as a username. Hopefully this will work. Oh, you know why it didn't work? To do a stable structure. So yeah, that's one limitation. So I'm going to restart the replica clean, which means it'll wipe everything. You can't just change the type of your stable structure once you've initialized it. So once I put a stable structure into memory ID 0, then you're just stuck with that. There's no migration process yet. So that's just a little limitation. That's just something we need to fix. It's like shouldn't be too difficult to fix, but we just ran into the problem. So, and then yeah, let me just see any other questions. Let's see. So using Kybra, I could log into any DApp with the generated II. I'm not sure what you mean by that. Anybody who has an II, like they could log into your Kybra application. If that's what you mean, definitely. Maybe clarify that if I didn't answer that correctly. And then, is there plans for a continuous smart stable structure detection so you don't have to run it with clean? Yeah, you basically want migration. So yes, there are plans for migrations. But this is just a fundamental limitation of, to some extent, it's a fundamental limitation of the internet computer. You are going to have to deal with migration somehow, and they're actually very, very complicated. So you can't just expect to change the type of your stable structure if it has data in it and just deploy that and expect it to just magically work, you're gonna have to figure out how to do the migration. So we will help with that because we can do some of it for you automatically, but realistically, it's just like a database. Like once you've created your database and created the tables, you can't just change your table structure and hit deploy and expect it to work. You might, some of it can be automated, but oftentimes you'll have to actually run some scripts that can manipulate the data and do things like that. So, okay, that deployed. So it should work this time. Oh yeah, I think it changed the canister ID on me. So, all right, let's try this. There we go. Now let's make an actual user. Okay, now query, there we go. There's our record. ID 0, H32, last images. That's basically it. I feel like it's a good place to stop. So happy to answer some more questions in the last couple minutes. Let's see. Say I want to make an app that offers a custom UI for a dApp, like how Reddit or Twitter has third-party apps. Could I do that using Kybra? It all depends on the HTTP functionality that those applications require. So I can't say yes for sure, but I would guess that you probably could. One thing you have to keep in mind is any kind of API key or secret key or whatever that you store in memory is technically easily obtainable by the node operator. So you need to keep that in mind. And it just all depends on like the HTTP headers that you need to exist and all that stuff. So you'll just have to play with the HTTP functionality. It looks like this in Azle. Well, I'll just show you in Kybra. It looks like this. Here we go. So to do an HTTP request, or to receive an HTTP request in Kybra, you just make a query method, call it HTTP request, and you get a request object and you return a response. They're type dictionaries actually. So here's your request dictionary. It gives you the method, the URL, and a list of headers. And the body is a blob, which is bytes. And then your response could be a status code, headers, another body, and a couple other things. So if you can shove all the functionality into this, then yes, it would depend on the application. Lots of people are building Python applications using ChatGPT, OpenAI. How much friction do you see in deploying a related application? I'm particularly concerned about time to query OpenAI API efficiently. Yeah. No, if it needs to be real time at all, like if you expect someone to type something and receive a response like as they're typing, kind of like the ChatGPT UI, that's definitely not going to work because HTTP requests take like 5-ish seconds or longer because they have to go through consensus. So that will not work for real time stuff. But if you have, for scientific type computing, you might be able to do inference on the internet computer. So if you train a model, and you possibly could take the model and deploy it and execute it. Once we don't have the standard library working fully yet, so it all goes back to the wasm binary limit. It's just the standard library is too big to deploy. Once you have that though, assuming you could get your model to run with just Python, perhaps that could work. You might run into the query threshold limit. And then if you want to train something, you could possibly use Kybra to do some basic training. The problem is if you have heavy compute or real-time compute, the internet computer right now is generally not a good fit. So you would have to keep that in mind. And I guess my time's up, so I think that's all.
Awesome. Thank you so much, Jordan, for your explanations. I think it's really useful for students. Yeah, thanks a lot. And now the second part is the workshop will be handled by Kanishk Khurana, developer relations at Lumos Labs. He's a Web3 developer with a strong background in community building. He will share insights on the various software development kits that make dApp development easier with tools like Covalent, Biconomy, Push Protocol, Third Web, Wallet Connect, QuickNote, Infura, and Polygon. Thanks, Kanish, for your time today. I will now give the floor to you. Thanks.
Wow, thank you so much, Javier. I mean, I'm super happy to be here, super excited to be speaking to such lovely devs. I'd also like to thank the previous speaker. I think the session was really intriguing, I would say. Very interesting as well, because even I got to learn so much about heaps and how data structures were interacting inside the environment. And it was truly, truly energetic to see how we handled all these problems that also occurred while development. So lovely to see all of that. And with all of this said, now let me just quickly present my screen. Hold on just one second. And apart from also the SDKs that we'll be talking about, I'll also present some code here and there. He knows. Oh, Jordan, you're too kind. So I hope I'm properly audible, right?
Yeah.
Awesome, awesome. Cool. So I'll just present my screen now. Here I go. Yes. I should be live right now. Let me just have a look. Awesome. Cool. So different SDKs to build better, right? Um, I would say that this is my personal opinion that when we talk about building on the blockchain, right? When we talk about exploring different projects, different ideas in this Web3 world, obviously we can interact with different kind of environments natively, right? For example, if you want to connect a wallet to your application today, say a MetaMask wallet, what do? You simply call the Ethereum object from the Google, the Google objects, and in this Ethereum object, you can simply call and connect your wallet. But if you want to connect multiple chains at the same time, how do you do that, right? And obviously you can figure this out, but how do you quickly do that in a way that is not very expensive, quickly implementable, and obviously maintainable? This is something that we'll be talking about in depth today. So we'll be exploring different SDKs, software development kits, as you all already know. We'll be talking about how to solve some issues that happen with these kits, because obviously they're all under development, right? And they're all open source as well. So if you feel that you can build better than what is already there, go and contribute. I'll be sharing a lot of GitHub repos throughout the session. So ensure that you're checking them out, if not contributing. And obviously, through my experience, I have been a part of ETH India that happened a couple of months ago here in Bangalore only. I've mentored a couple of hackathons around India and obviously internationally. So with this experience, I have shortlisted a couple of SDKs and tools that will definitely help you in the longer run. I'll give a small walkthrough from their docs. A couple of them, for that, I'll show the GitHub repo as well. And since I'm a front-end developer, so I'll share a little bit about a couple of quick ways to adapt to these particular SDKs on the front end as well. Okay, so somebody has a question in the chat as well, which suddenly got my attention. What if you want to implement a call for Unreal Engine 5 for P2E game in ICP? I guess that is a question for Jordan. Awesome. Cool. Let's move forward now. So a little bit about me now. Who am I? My name is Kanishk Khurana. I am a developer relations engineer at Lumos Labs, and I work on full stack apps, blockchain projects, and I love building communities. I love to talk to people, figure out what they're building, if they have any problems or not, and just in general talk about technology, right? That is something I genuinely love to do. Prior to being in the blockchain field, I was building Web 2 applications for almost 4 years. So yeah, I have a vast experience building on React, MongoDB, the MERN stack, as the cool kids call it. And yeah, that's sort of what I do. So if any of you want to get connected with me, here are my socials: Twitter, LinkedIn. I love to talk about tech. So that's sort of what I do. Now let's move forward. I'd love to share the agenda for the day. Agenda, right? So introduction. We are already past that, right? Next up, obviously, we'll dive straight into the different SDKs and all. Post that, I want to show you something that we have been building at Lumos Labs ourselves, which is the lovely metaverse that we, carry with pride, as you can see, into the metaverse, right? So, what is the metaverse about? How can it help you? And the skills and the ideologies that you will learn today, how can you quickly upskill yourself using them in the metaverse? That is something we will be talking about. Obviously, throughout the session, please feel free to ask me anything. And if these are bugs that you're also facing in your code, let's unveil them together, right? Let's solve them together. And obviously, I would also love to talk a little bit more about the communities that we have around and how can you also be a part of it. So stay active and keep asking doubts. um, if anybody has any doubts, please don't feel hesitant. You can simply unmute and start speaking. I do not want this to be like a classroom where, I speak, you listen, and then you go. Let's keep it like we're friends, right? We're just talking. Come on, you're a developer, I'm a developer, and we're all just here talking about things we do to earn a livelihood, things we genuinely love, right? So let's keep it very, very open. Awesome. Um, I hope you're all as excited as I am. Let's get started. So yeah, first of all, we're already done with the introduction. We already know what we're here for. Now let's talk about the simplest and the most important tool that I want to talk about today. This important tool is called Wallet Connect. Again, I would go back to the example in which we talked in depth about this thing, connecting a wallet to an application. Today, if I build a React app, what is the process for it? Absolutely simple. In this, npx create React app, name of your application, blah blah blah. You go all the way forward. Extensive question for this work. I was curious about some couple extensions or resources paid used to how to embed data sets, etc. Okay, I think Julian has a question for Jordan only. Cool. I have an eye on the chat as well, so that's why I keep redirecting to it. Cool. So again, the MetaMask extension, when you download it to your browser, it injects the Ethereum object. You call this Ethereum object through a particular function that you write in the React app. And then through that, you trigger a wallet. For those of you who are sort of confused what I'm talking about, let me quickly pull up the GitHub repo that we have for this, so that obviously you can refer to these examples, and I'll obviously split my screen share right away. So where's the app? Where's the app? Where's the app? I have one right here. Yes. Just 1 second. Let me switch my screen. Okay. So I would like to bring everybody's attention to this particular tab that I'm sharing now. I hope it is visible. Yes, it is. Cool. As you can see, I am calling the Ethereum object from the window, document object model, right? And in this particular function, those are just, a different trial and errors that I was doing. But this is the particular function that you should pay a little bit attention to. Let me zoom in a little bit here, right? So as you can see, connect wallet. If you do not have the Ethereum object, it will alert you. But if you do have it, it will quickly call the accounts in it and it can set it for you. Simple, easy, straightforward. If anybody has been struggling with this, I hope not. This is sort of beginner level difficulty. But if you've been struggling with it, no problem at all. You can take a screenshot and you can reach out to me later as well. We'll talk about this. So basically what happens in this is that you call the object and you connect. But say you want to connect different chains as well, right? Say that you want to ensure that not just MetaMask, but you can connect BNB. You can connect, Trust Wallet. You can connect a Glow Wallet, whatever kind of other wallets that you want your app to be open to. You want your DApp to be open to. Wallet Connect is one of the fastest ways you can do that. And let me just talk a little bit about what they do and how they do. So basically, it's a very plug and play interface. You import 2 modules. One module is called Web3 Modal. The other one is called Web3 Wallet. Simple as that. You define the chains that you want to build upon. And finally, you call those chains. Let me open up their documentation so that I can show that in a better way. Here we go. Let me shift my tab. And here it is. So as I mentioned, Web3 Modal and Web3 Wallet are 2 of these SDKs. If I go here and I talk more about Web3 Modal because it's sort of mainstream, and I mean I like the the UI as well. Looks pretty cool if you ask me. Being a front-end guy, I think UI is where I also waste most of my day, just aligning divs. So this is sort of cool. And as I mentioned, see, you just import 2 major modules right here. These are just helpers. Ethers, as you know, it's used to call the Ethereum blockchain and all. Wagmi is just a hook library for Ethereum. So yeah, this is basically how you move forward with it, right? You import a couple of, what do you call it? A couple of components, right? And then you use those components in your app, right? Now, of course, it provides a lot of benefits and you can move on with it. But the story does not end here. Let me take all of you back to the next one. Now, this is Biconomy. Let me just present, right? So this is Biconomy. Biconomy takes it a step forward. Cool. You want to connect a wallet to a particular dApp. That's perfectly okay. But just like in the Web 2 world where we have centralized servers and we have Google Auth everywhere, right? How can you provide something that is similar to Google Auth in the real world, in the blockchain world, right? That is something absolutely interesting. And luckily, Biconomy has been able to figure it out. Do we have people in the audience who heard about Wallet Connect or Biconomy before? By the way, these are all products of a hackathon. So I think that is something really cool about the Web3 ecosystem, that hackathon projects, they come out to be one of the most famous and the most useful products out there. Okay, so it looks like we've not really heard about Biconomy or Wallet Connect before. That's okay. That's okay. Never developed with them, but I've heard of it. Oh, that's amazing, Michael. That's amazing. That's amazing. So cool. Let me show you some code here and there as well, just to clear up some barriers that you will have when you will start developing them. Michael, what is your major tech stack? Do you build on React? Do you build on Vue, or just plain HTML?
Sure. So currently, I am a engineer at BitGo. So we're a crypto custodian, and the main tech stack that I work on is like TypeScript and JavaScript, importing other chains as SDK onto the BitGo like wallet platform, as well as I do a lot of Java for the BitGo like indexer as well.
Wow, that sounds absolutely amazing. So what I want to share is going to be really cool, because gasless transactions with a social auth is something pretty cool. And how Biconomy actually implements it is also pretty tricky, but I'll try my level best to explain it in a simple way, right? Cool. Let me now move forward with the next feature that they have is also what I've mentioned already, gasless transactions, and then finally enable off-ramp and on-ramp fiat transactions. So with this one wallet that they provide a particular user, they are able to maintain all of this. Now, let me quickly bounce back once again and show you guys how we enable wallet connection, social wallet connection in the Biconomy dApp, right? This is a particular repo that they are maintaining. I've also contributed a little bit to this. So that is why I refer a lot to GitHubs, because they are easy, right? And if there are any issues, then we can all work on it together. So a very simple next step, this is, you see, the README has also not been touched at all. So basically what happens in this is you go to the pages, which is index.typescript. And the only thing we import here is the social logic dynamic. Kanishk, what is this name, social logic dynamic, and why does it sound so weird? So a couple parts to this, okay? Now stay with me. This is interesting. Basically, the social logic dynamic is a component, right? And this component stores all the features inside it that helps you connect to a social, that helps you connect to a dApp using the social login that Biconomy provides. But in this particular social logic, they have obviously a class of social logic, which gets implemented, and it's a pretty huge pile of code. You need not manipulate it much because it always works in the same way. And they have provided it in the documentation. Now I'll be referring to that particular file, which is this one, SCW. So they have, they've made it very modular. I would like to just simplify it by saying that instead of just, making another component folder inside the next app and then importing it, you can just simply refer this particular file right here. scw.tsx is the one I'm talking about. As you can see, you need to install 3 packages here, right? And now this goes way beyond what Wallet Connect was able to do, because you get all these features like gasless transactions and off-ramp, on-ramp fiat, and a couple of ERC20 tokens as well that you can manipulate using this. So it's pretty cool how they implement this. Let's dive a little bit deeper into the code and try to understand how they do it, right? So first of all, chain IDs, right? Absolutely simple, right? This is only used in one place, which is on the test net. Here you go early chain ID. That's all. Okay. Next up is the social login. This is the actual package that you will be using. And this is the smart contract package. Now, smart account package, sorry. So what essentially happens is that when you log into a particular dApp using the Biconomy smart social login, you are actually interacting with the smart contract, right? But since this is a social login, so Biconomy puts a layer of EOA, and this EOA is actually what is helping you implement changes onto the particular dApp. Now let's dive a little bit deeper into it. I know I'm covering it very layer by layer, but that's because this is a complicated topic, at least for me. When I started off, this was super difficult to understand. So I want to make everybody very, very comfortable with these words as we unravel them. Again, couple of hooks of React, right? Set state, we are creating states and we are creating the function to set those particular states whenever needed. And use TypeScript here. And there's a quick hack that we have in TypeScript that if you do not want to define what a particular type is, you just put any. So they started off with that already, which is pretty cool. I mean, I don't have any problems with it. And this is especially helpful during hackathons, right? So you can quickly scale up the project and present something good on the demo day. Cool. Yeah, then finally the smart contract. This is actually smart account. Sorry, I keep saying smart contract. Smart account is imported right from here. And we can, now let's move forward. So as I mentioned previously, when I showed you a function to connect a MetaMask wallet to a particular dApp, here I have a connect Web3 wallet, which is basically how Biconomy implements it, right? So if the window is undefined, again, return. You can put an alert statement here as well, like I showed previously. Again, let's move forward now. Console logging just to check whether you're working properly or not. Your Web3 providers are also the same, just like you did for MetaMask using Ethers. You're using Ethers here as well, exact same process. The difference that actually happens is from line number 31. This is where the change actually happens. So you verified everything up until this point and things are moving exactly how they move for MetaMask. But now, once everything above here is verified and you've set a wallet, now is the time that you actually show the Biconomy wallet and you are able to connect to it. This is where you initialize that particular wallet, right? You are, again, we are importing everything from these two particular packages and we're using them right here. Once you see the wallet, you are able to return the wallet. That means everything is working in the particular function. And here you go. Cool. Again, chain ID imported from here. Again, it's a very simple concept. If in case somebody feels that this is not simple, because I'm quite moving fast when it comes to beginner topics, please ping me right away and we'll talk about them in depth. Right. And yeah, again, simple stuff, use effect, the function that gets called whenever something changes in the account or in the social login SDK. And we just run this particular task again. So if you're already connected to the particular wallet, this will not show the wallet again and again, which is a user experience feature that they've added. And I think it's a cool one, right? In fact, when we also create dApps, this is the first set of rules that we create. Like if you're already connected, the app should not show the wallet again and again, and your user should have a good flow. All simple. Cool. Now let's move forward. Again, a couple more features. You can disconnect your wallet using the .hide wallet function right here. So these are just basically functions. Let me pull up the documentation for a second to make this process a little bit more simple. One second. Here we go. Yeah. So this is the Biconomy documentation for you to quickly go through these concepts in a little bit more detail in case you forget after the session. So in it is basically initializing, show wallet is showing the widget, hide is hiding the widget, log out is logging out. Pretty straightforward functions, and you can implement them like this as they have provided here as well. And just as I showed you in the code a couple of minutes ago. Okay, so yeah, that's basically it. I hope everybody is excited about using Biconomy in their own applications as well. I just wanted to show the social login feature. Gasless transactions is again something that is sort of tricky, but I would love to cover them right away as well. Gitbook is sort of lagging, but here we go. So the way they pay for gas for you, basically what happens is each time a transaction happens on the blockchain, obviously gas needs to be paid. But who pays the gas is basically what makes it gasless here. So the way Bioeconomy itself explained it to me was that the DApp itself is paying for the gas using the gas stations that they have set up. Again, too much in depth, we won't go today. It's beyond the scope of today's session. But if you're interested, obviously, we can do another session beyond that, regarding that as well. And I'd leave the Bioeconomy docs link as well. And obviously, you can take references from my deck as well. So that's sort of it. That is all I wanted to cover for the Bioeconomy part. Now let's move forward to the next one, which is Third Web. And this is by far my favorite. Has anybody here heard of Third Web? You know, you might have met a couple of their developer relations guys as well. Amazing team and a really, really good community to talk to and to interact with. Yeah, CC used it for DAO with friends. You were doing a hackathon. The Third Web is awesome. I absolutely agree. I explored Third Web a lot during ETH India because, you know, I was mentoring there and I saw a lot of students struggling with concepts like, you know, smart contracts. How do I deploy? How do I, you know, use different features? I want to make my own coin, but I'm unable to. So this is something that now, and by the way, this is happening like 2 hours before the submission. So I used Third Web right away. Help my system with NFT collection. Wow. Wow. That is absolutely amazing. Like, I should introduce my own sister to Third Web as well now that you've mentioned it. This is amazing. So yes, absolutely thankful for the kind of work they do. You know, the cool part about this is I don't even have to open the documentation for it because the website itself takes care of everything that I want to talk about. So let me just quickly open the Third website and how it can help you scale up your project right away. So first things first, SDKs, right? Today, when I want to code a smart contract using Solidity, I go to Remix, remix.ethereum.org. Amazing development environment. And I've used it countless times for sessions and for development purposes. But say you want to do it in VS Code, right? You want to import something that you've made there in VS Code, test it in VS Code, and obviously deploy it right here. How do you do that? Well, this is the first question. Frameworks like Truffle and Hard Hat help, but this comes power packed with more features, right? So now you don't only have a package to help your smart contracts, but you have some dashboard components as well to maintain these applications, to see what kind of activity you're having on them. And as our members also are talking about today, you can deploy proper collections using their low code or even no code interface and quickly scale up during a hackathon or during a client meeting or something. Many a times during sessions, we talk in depth about how they implement these features. And today is obviously one of those days. So let me just quickly pull up the documentation part. Hold up 1 second. Correct. Awesome. So here's the first one. SDKs, right? What kind of SDKs do you have here? So I am a React developer. That is something I'm most comfortable with. I also saw somebody, I think Julian was talking about Unity, right? So Julian, if you want to explore, here you go. Unity support is also provided, which is something that I've never seen happen in any other development kit before. So I think this is absolutely amazing. So which contract do you want to use? This is the contract address. Obviously, I don't think that this will exist in reality on Etherscan, but you get the idea. And looks like this is for NFT. So basic implementation looks pretty cool. Front-end applications. Let's explore them a little bit first, because again, this is what I do. Simple npm command, manual installation, and even simpler than I would say Bioeconomy or Wallet Connect. Right up front, they show you that you just need to use the Third Web provider, wrap it around your application, and you're good to go. I remember using this in the central data store in a React app, for example, using Redux, or even using something like Context, right? So nowadays things have become very, very simple with robust APIs and caching your data. But wrapping around an app is obviously the simplest way to go around. And interacting with different contracts is also here. So ERC 721 is your NFT. Instead of racking your head on how to build a particular contract and how to actually call it in a particular app, here you go. This is the simplest way to move forward. You don't waste much time and you quickly upscale. Now, I am genuinely not against building things from scratch. Believe me, when I was prepping for this particular session and trying out all these SDKs, I was building things from scratch. But if I get an interface where I can just test things out quickly, where I can just try them out and scale my app quickly, why would I not go for it, right? This is where things come into picture. And right now I'm speaking to the developer crowd, right? This is the crowd that will be solving the problems that people are facing all around the world and building good solutions. But I feel that there's also a big sector of people who can't code, but they have a really good mindset when it comes to solving these problems. And using the third web interface, you can absolutely do that. We already have a couple examples in the chat, right? So that's what this particular Kit SDK and dashboard also is all about. I would go a step backwards. Wait 1 second. Awesome. Here we go. 1 second. 1 second. Okay. Now here is the next feature. You want to try out a couple of smart contracts. Here you go. They're all ready made. And they have some pretty cool features. So if I explore this particular, page not found. Well, this is not a problem I'm exploring for the first time where pages aren't being able to see, but it's all right. A couple of interfaces that they provide already is ERC720, build your own mutant API club. Who doesn't want to build the next, unicorn NFT collection? So using this, you can absolutely explore that. And the biggest factor that I feel here is the fact that they have a really good developer community. You have some problems with third web, you can reach out to them directly on Twitter, and 100% they reach out every time. So during hackathons, absolutely helpful. Building faucets, for example, absolutely helpful. And this is something I genuinely appreciate, and which is why I wanted to bring it to everybody's attention. We should support these kind of developers and communities, and obviously grow and learn with them. So that is basically all I wanted to cover when it came to third web. If anybody has any questions or wants me to explore a little bit deeper into these particular SDKs, do let me know. I think a couple of us have already explored it, so I won't really waste much time and move forward now. So now is the time actually that I take everybody through what we are building at Lumos and why am I so excited to present it. My screen is, yes, appropriately visible. But before I get started, I have a very small question. Are there people here who have played games like GTA San Andreas, Super Mario, any game where you had a free roam feature available? These days, I see God of War or even the recent Harry Potter game that has been released. Absolutely amazing. So I have played games where I was able to explore the real world and just roam around and talk to people. Anybody else in the audience? You can just say yes in the chat. It's all right. I won't ask you which game. It's okay. Awesome. Awesome. Cool. So I think one of my most fond memories and the most amount of friends that I've made is in a Counter-Strike lobby when I was in high school. Because, it was just a cool place to be, and I genuinely enjoyed the environment. Then I grew up. It was time to learn more skills, time to build good stuff, and obviously get a job. But it was super tough to get a job as a software engineer, right? I had to fill 1,000 forms, then do assignments, lead code crazy for 6 to 7 hours a day, and then face those same questions in interviews and panic. So those were some major problems I have faced, and I'm sure all of us have faced. But now that we have decentralized solutions available that can track your progress and show people the proof of your work, why don't we leverage all this energy, leverage all this power, and build something, right? So that is what we have been building here at the Lumos Labs headquarters, and that is what I'll be presenting, the Lumos Metaverse. Let's dive deep into it now, and I'll talk more and more about what we are focusing on. So Lumos Metaverse is a place for developers and developers only. It is a place where you can learn, earn, grow, network with people, and host these kind of events, but in a much more comfortable and communicable manner, right? Let's dive deep into it now. So this is what the Lumos Metaverse will actually look like. And yes, this is the exact design for it. I'm not bluffing. We've literally taken screenshots from when we were trying it out and building it. And let's dive a little bit deeper into one of these buildings, right? So this is what a particular building will look like. And this is where you can run operations, you can get hired, you can explore opportunities and massively grow your developer potential and developer team as well if you want to hire. Let's see what all kind of advantages do we get. So yeah, obviously you get to meet companies, grow with people and communicate and grow your network. These are some companies who already brought these buildings and they already wish and are going to run these operations with us in the metaverse. Let's enter one of these buildings to see what it's all about, right? Once we go inside, this is what a particular landscape will look like. There will be a screen up front, there will be places where you can walk, there will be people you can talk to and explore more and more opportunities. We're also coming up with a learning portal to help web 2 developers and web 2 enthusiasts scale into the web 3 world, where they can quickly learn about decentralization, quickly learn about blockchain and quickly upskill themselves. Awesome. Let's interact with this particular card as well and see what it's more about. So obviously learn, earn and get hired. I've discovered and talked a lot about these opportunities already. Let's dive deeper into them. So this is a snapshot from one of the sessions that was happening, right? These are actual people around you. This is what you will look like. And somewhere around there is what I will look like. You can obviously talk to people in your proximity just as you would do in the real life scenario and just as you would do in a game, right? So this brings forward a very gamified experience that you can explore and obviously have a lot of fun at. Talking to people online is fun, right? Discord supports it, Zoom supports it. But I want a better experience, right? Where I could genuinely just walk up to a person, ask, learn, and hopefully get hired, right? That as a developer looking for a job, that is something which makes my hard work really, really worth it and really convenient for me to just get hired, right? Let's interact with this particular card, attend global events, right? One of the greatest things that's happening right now is I'm able to interact with people sitting in Vancouver through Zoom. But I would want to provide a better experience using blockchain, using Metaverse and all these futuristic technologies to all of us here. And that is where the Metaverse comes into the picture. And obviously, this is what a particular dashboard for you will look like when you will get onboarded. I will be sharing the whitelist QR code very, very soon. And we'll be providing NFTs for entry to the particular Metaverse. Right? So please fill that out. I'll be sharing it very, very soon, right here only. This is what your dashboard will look like. This is how you'll chat with your friends. All of this is ready and we'll be launching pretty soon. So let's see some opportunities. One of the craziest things that we have here is that all your skills, all your hard work that you've done in life will be stored in one place and one place only. So this is why you don't have to worry about filling 1,000 forms, proving your worth again and again, and wasting time doing menial assignments where you could be actually, building something cool. And that is the point of this resume and the point of decentralization in the metaverse, right? So it's a culmination of a lot of cool technologies, and this is what we are bringing forward to developers. Pretty cool for me. Let me know what you guys think. If anybody has any feedback, any questions, I'd love to hear more about this. And obviously, we look forward to improving this in the future as well as we keep building. And that is where you developers come into the picture. So this is the QR code for the Metaverse whitelist. Please scan it and fill this as soon as possible. In case you feel there's any problem, any disturbance in filling this particular form, do let me know. Somebody's texted in the chat box. Where is the QR code? My stream is lagging. That's completely okay. I'll just share the link in the QR code as well. Once again. Yeah, there we go. Awesome. There you go. Culmination of a lot of ideologies, technologies, and developers. Right. So the kind of audience I love talking to. Cool. With this, I come to another SDK, or rather, I should wait a couple seconds for those who are checking out the form. Right. I'll give everybody a second while I grab a sip of water. Awesome. Cool. While you guys are filling up the form, I assume, I I would like to talk. I'll just like to give an introduction to push protocol. So push protocol was initially called EPNS, right? Ethereum Push Notification Service. We all know what push notifications are, right? Those are the pop-ups that come on our phone when we are trying to focus on work, right? The pop-ups that come on Instagram when we are trying to figure out bugs in our code and they distract us. Push notifications. So push protocol exactly is something that deals with push notifications on the blockchain. So the way they handle this is that they have channels that are connected to all the chains. And whenever you want to subscribe to a particular activity happening on a particular chain, you can just call that using an API or a call to your front end, and it will show in the form of text, right? So just as a normal API would work, a REST API, that is what I'm talking about, where you want to get information. This is exactly what push protocol also does, but on the chain, obviously. So cross-chain notification channel, different chains can come together. You can bring them on the same dashboard, call them and talk to them, right? One of the coolest things is that a lot of my friends also work here, and they're increasing the support for different chains every day. Integration is something that is very prime here, and talking to different chains is obviously not easy. A lot of other SDKs are also working on the similar problem. For example, the router protocol. And cross-chain communication in itself is difficult, but making a notification channel on it is somewhat simpler than communication, right? Because you just need to subscribe to events. And then when these channels are ready for you on different chains, you just need to call them onto the front end, right? Cool. Let me quickly grab the GitHub repo that I have for this and talk a little bit more about the SDK functionality in its own, right? Let's start with the package.json so that I can show you the two particular packages that you would need for this. Obviously, the first is the REST API package, as I mentioned, so that you can make calls onto the front end. And the next is the socket package. So if we are aware, whenever we want to initiate conversations onto an application, we use something called a socket. Socket is when, different applications, they get stuck on ports, and these ports then help us communicate. So you don't directly communicate, you communicate through a socket, right? This is what push also is working with. They have different sockets for communication. Awesome. Let's go back a little bit now so that I can show you some front-end integrations and some channels that they have worked upon. So your app modified and your app OG. Nice lingo, by the way, OG. Cool. Let's look at the project structure here. So yarn is the default template, not really NPM. I'm super comfortable with NPM, but it's all right, right? Again, it's a React app, not a Next app. So that is something, if you want to, keep in mind, that's all right. Let's look at some contracts as well here. Okay. So looks like they're only calling one contract here, and this is the contract that I think it's also on their website. So using this particular contract, they handle a lot of cross-chain communications. So basically, again, it's smart contracts calling different things, right? Please don't think there's a server calling any of this. Obviously, there's smart contract calling all of this, and this is the deployed contract for it. You need to just replace it with your own contract when you create your own channel. So channels for communication is what they are referring to, right? Let's go back a little bit, to the React app. Source folder, different components. Actually, before the components, let's see what they have in the index.js, right? So as I mentioned previously as well, we'll be covering a lot of different tools and all as well. So Infura, right? Are we aware of what nodes are for blockchain? I mean, of course we are, right? Quick node Infura, what do they do, right? Zeep protocol is also in the similar realm now, where they provide nodes for you to communicate with information on the blockchain. So this is the Infura node ID. Please change this to your own one if you are planning on using this. And just wrap your app again. Simplest process, right? Just wrap your app. You don't need to worry much about the APIs then, and everything is handled on its own. Let's check out some components here. Only one component. That's absolutely amazing. So styles are all present. Cool. Nothing too complex here. These are all style components. And that's about it. Nothing too crazy here to talk about, to be very honest. The process is absolutely simple. Create a contract. I'll share the docs in a while in the comment in the chat itself, so you can actually see what a contract here looks like. And we provide a repo with all of these things that we've talked about, so that if you want to refer back to this code, you can do that, right? So majorly, that is what push protocol also deals with. So if you want to generate notifications on particular events in your application, for example, say you are running a bot that is doing transactions on the chain for you, but you want to create a stop loss statement here where you want to ensure that the balance does not go lower than a particular amount. Just create a notification for yourself, right? So that's what it basically deals with. Cool. With this, let me come back to the deck, and majorly that is all I wanted to talk about. I would love to make the floor open to other people as well. If anybody has any questions, if you think I missed something, or if I did not explain something in its entirety, please let me know. I would love to just, catch up again on a particular topic. That's about it. Next up, I would encourage everybody to join our Discord server as well. This is where conversations like this happen every day. We have guest sessions, we have actual coding sessions. I showed a lot of GitHub repos, but it was not physically possible to code all these in one go. But we do that on the Discord server. So just scan this quickly and join if you feel comfortable. Say hi, say that, hey, we met Kanishk here, and I'll also say hi. Just make good relations with people. And yep, finally coming to the community angle, which is why I asked people to scan the Discord, is because we are also trying to build this developer community in the real world, obviously. So we are running a lot of open source initiatives on our GitHub. If you go to the Lumos-Metaverse GitHub organization, you'll see a lot of projects that are being built by our community, and we just help them out here and there. So we've done a lot of workshops like this for beginner level developers as well, people who are still in college, still trying to figure out whether they want to pursue this or not. And we find it to be really interesting that we get to speak to all these developers who are just budding, right? So they just literally learned React last week, and today they're building on the blockchain. And we just help them in this process and make good friends along the way, just like I made a lot of good friends here today as well. So that is the community we are trying to build, and we maintain it via Discord right now. But obviously it will shift to Metaverse very, very soon. Awesome. Finally, here's the Metaverse QR again, just enforcing it. Awesome, Michael. Thank you so much. It was lovely having you here. And cool. With this, I come to the end of my presentation. Thank you so much for having me. It was a pleasure talking to everybody here. And the floor is open. If you have any questions, reach out to me, reach out to us. And I hand the floor back to Javier. Thank you so much.
Thank you so much, Kanishk, for your presentation. Great presentation. Yeah, thanks for sharing your knowledge with all the participants here. And yeah, this is the end of the workshop. We are on time now, exactly 4:30 here in Vancouver. Yeah, I think it has been useful for you, for all the people here. The Jordan and Kani showed up really good tools for devs. Yeah, thanks for your interest. Really appreciate your interest to know more about Demergent Labs, Lumos Labs, Internet Computer, and all the tools that Kanishk showed up. So Dash, yeah, thanks again, Blockchain at Michigan, especially to Sohavni Singh, the Vice President, to organize this event. Thanks as well to Kuri and Zakaria from Lumos to help me to organize the event, the workshop. And for sure, thank you to the speakers, Jordan, Last, and Kanishk, for all your time. And yeah, see you in the next event. Have a wonderful day, and thank you so much, everyone, to participate today. See you soon. Bye.